Well, as Jillian said, I'm a sociologist. You'll notice that sociology doesn't show up anywhere on the screen here. So what does a sociologist got to say about aquaculture? Can you hear me in the back? How's the volume? Do I need to put the mic on? Mic? Okay, I'll mic up. So as I was saying, you notice sociology doesn't show up anywhere on the screen here. I'm not disappointed or shy or reluctant to admit that I'm a sociologist, a card-carrying sociologist. I'm actually a rural sociologist. That's different than a real one. And it's different because we tend to be much more applied in our orientation compared to sociology, who does the more sort of basic work, and we're the applied social scientists. I've worked in aquaculture for a number of years, and marine fisheries as well, a number of different things. Basically, wherever there are people is the playground for sociologists. And that's not only in aquaculture, it's also in the area of ecology, because there are no ecologies without people. The last one that I know of, we poked a hole into it. It was 1,000 meters deep in Antarctica under ice, and we poked a hole down to see what was living under that pressure in a freshwater lake. So we've, So we're there too. So if we're having an impact there, we're having impacts pretty much everywhere. And in terms of public health, I'm talking to a bunch of experts. This is not necessarily my area of expertise. What I can claim is I was a Peace Corps volunteer in the 60s, early 70s, 3 years working in Malaysia, and I worked in public health, rural health. I dug wells. I worked in malaria eradication, TB control, and was involved in setting up a family planning clinic, the first one in a rural Muslim community in a county in Malaysia. I've also lived in Southeast Asia and elsewhere for a long period of time, and I've looked at the nutritional importance of seafood and fish in particular in the diets of people around the world. And in Alabama, I work on issues related to food security and hunger and poverty and issues like that. So that's my background. It's partly, I could say it's limited, everybody's is. It's also scattered pretty broadly and thinly around a lot of different things, I think, for better or worse. Jillian says that, and there are some seats up front if people want to move up. Jillian said that not everybody here is an expert on aquaculture, so I thought I'd put up just a definition so we have a starting ground. Simple definition until you start to look at it and realize there's a lot of moving parts, a lot of things going on in this definition of what it is we mean about aquaculture. It's not so simple. There's a lot of different organisms: finfish, mollusks, crustaceans, reptiles, all kinds of things that were going on in terms of aquaculture. We'll talk about a lot of that diversity as the hour goes on. There's a certain level of husbandry involved, meaning you got to take care of these critters somehow. Feed, protect them against predators, all kinds of predators, snakes, birds, cormorants, things like that. Other fish that may slip into the ponds and eat the stock that you've got. And you've also got human predators, right? People who come in and want to steal the products. You've also got to exert, and related to that latter point, some measure of control over the production area that you have. Property rights would be one way of phrasing that, but you need to be able to own and control the area that you're working in. Aquaculture takes place in many kinds of environments. This is a pond. It's in northeast Brazil. Notice the sticks. Those are to discourage human predators coming in with cast nets and coming in at night to take the shrimp, because the nets will get caught up in those sticks. So that's one way of protecting. Cages these are for common carp, and this is Lake Toba in Sumatra, island of Sumatra, a lovely lake, growing carp. You've got these small cages. You've got big salmon pens. This is in Norway. And for scale, that's a human being, right? So these are big, much bigger than those cages that you saw a moment ago. We also raise shellfish in a variety of different ways. Some you've got just sort of sticks up there and with ropes going along and little bags with oysters. A more off-bottom mechanism is this, and we could talk about that if you wanted, but I'm going to move quickly through that. And then you've got people out there tonging for oysters in Gulf of Mexico, and they're just, they may have in fact cultivated these beds, but they're open ocean, and same kind of thing you'd see in the Chesapeake. The point is, aquaculture takes place in a lot of different areas, and there are, I've only touched on the more important ones. There's also, this is just for Vietnam, but there's also roughly 300 species of organisms, I should also have mentioned algae, that are cultivated in aquaculture systems. Most of the effort in research, most of the effort in investment, most of the effort in terms of scientist hours is in a small number of species, notably salmon and shrimp. But there are many, many species around the world that are being cultivated, and in addition, we're working on developing some new organisms. This is a picture of the Aqua Bounty Technologies transgenic, genetically engineered salmon. The big animal there is supposed to be the same age as this other Atlantic salmon. Some of you may know about this technology. We could talk about it later. I'm going to move on right now. We're also developing, and this is work that's being done at Auburn University, which is a major center for aquaculture, an interspecific hybrid of the blue and the channel catfish. The channel is the main catfish grown in the United States. It's the largest industry for aquaculture in the U.S., but they're crossing it with the blue. And the hybrid of this animal is supposed to be not only grow faster, but it's supposed to be resistant to diseases, higher feed conversion ratio, easier to grow, more easy to handle, and a better dress out weight. So lots of good reasons to go play with the genetic stuff within aquaculture. On the other hand, this animal doesn't exist in nature, and we're going to put it out in ponds, and at some point, a bird's going to pick it up and drop it into a stream or something, and so there are the potentials of this being an exotic species introduced into the wild. There'd be issues. Okay, so that's aquaculture is very complex, dynamic. We're introducing new technologies. Aquaculture has grown dramatically in the last 3 or so decades to the point where it is a substantial portion of total fisheries production. Total fisheries production are about 148.5 million tons a year, 2008 data from FAO. Captured fisheries is the largest part. Aquaculture is about 41% of total fisheries production. Now that's including this 20 million tons up here, which is made up of what we call industrial fish. These are the capelins, and the menhadens and the anchovetas and other very small, relatively small fish that are captured in very large volumes and are processed into fish meal. So that 20 million tons doesn't go directly to human consumption. So if you just combine these two, aquaculture is 47% of all fisheries production consumed by humans as of 2008. It's probably gone up since then, but I don't have the more recent data. It's important. We import billions of dollars of seafood every year, and 80% of that is aquaculture product. So aquaculture is a very big item internationally. It's a major item in international trade. I'll come back to that latter point. Where does aquaculture take place? Usually where there's water. Good thing to have. But that doesn't mean that even where there's lots of water, that there's no competing uses for that water. This is in North Vietnam. These are areas that used to be in rice production, and the rice farmers said, we can make more money raising shrimp and exporting the shrimp for foreign exchange earnings. Who's against making more money? That's great. We're not growing rice for domestic markets. We're producing a product that's going into international trade. There's conflict between the uses of land and water resources, even when they are relatively abundant in the sense here of water. The point is, there's competition. We make choices when we invest in one activity or another. Sometimes, this is South Vietnam, Mekong Delta, sometimes water is too abundant. The blue area here shows what would happen with a 1 meter sea level rise. As I'm sure you are all aware, with global climate change, a variety of things happening. One of them is the gradual elevation of sea level. And this is an area where, in part of the world, not the only one, Louisiana is another, where deltas exist and they're very low-lying areas, and you're likely to have sea level rise inundating areas that are currently used in production. This is taken from an airplane in the north coast of Java, and you can see that this is an area that also, if you had a 1 meter sea level rise, sea level is going to be, where is it? It's going to be way up in here. That's not much elevation involved in. And so much of the area involved in coastal aquaculture is quite likely to have serious struggles as we move into global climate change and sea level rise. So the availability, or too much, water are issues. Sometimes we have actually moved aquaculture operations away from, in this case of shrimp, away from the coastline because of disease problems and other issues, and moved hypersaline water in trucks in Thailand, hundreds of kilometers away from the coast, and are growing shrimp in the interior of Thailand. It's now banned by the government, but what the government says doesn't always work when you have a lot of money to be made by doing something like raising shrimp. What happens is, as you have brought this saline water up to raise the shrimp, you have salinized the soil where that used to be rice fields, and there are rice varieties that are salt tolerant, but you have a long-term impact on the soil. We're doing this in Alabama too. We're not trucking hypersaline water. In this case, this is a farm in West Alabama where they are using fossil seawater, drilled from about 700 feet deep in the Utah aquifer, pumping it up to the surface and raising shrimp in ponds. That's fine. Coastal lands are relatively expensive, lots of competing uses. This is an area that's relatively poor. Land values are relatively low. But that land is now salinated, and that's going to have consequences for its alternative production. Once they get to the point where they're no longer raising shrimp there, there are going to be consequences for this landscape. Plus, when they discharge the water into the wild, that's salt water that's going down into freshwater streams. Sometimes we raise fish even where there's not a whole heck of a lot of water. Okay, so you got catfish and shrimp farming in southern Arizona, a pretty arid environment. The Israelis raise tilapia and other species in desert lands where water is a precious commodity with geopolitical consequences. If you know anything about water, think about just for a moment the consequences of using water in the Middle East and in Israel in the context of Jewish and Palestinian relationships. Using water in that kind of condition, there are resource conflicts when we talk about using water in aquaculture. These are some of the ecosystem implications. We also have issues associated with diseases. I'm a sociologist, it's not my main area of expertise, but diseases are a significant threat to the ability to be successful as an aquaculturist, keeping your animals alive. Water is the integrative factor here in aquaculture, water and people. And in terms of water, if you're an aquaculturist trying to raise animals, keeping them alive, where's the water coming from? You got to know about what's going on upstream. What happens upstream? Think of where you live right here. What's going on upstream from here? You've got agriculture, you've got ag runoff, chemicals from agriculture, industrial, stormwater runoff, and wastewater treatment, discharges. Storm events happen, you have all kinds of problems that could exist. Think of the toxic stew that emerged after Katrina in New Orleans. So water is a conduit for lots of different things. Nutrients, oxygen, pathogens, chemicals, pollutants of all kinds. And these can affect what you're trying to raise. You can end up with massive fish kills. Sometimes we contaminate the groundwater where aquaculture is located because we're pumping fresh water from the aquifers up into our ponds, and particularly in the coastal areas, you may end up overexploiting those coastal aquifers, allowing for saline intrusion. So human populations that live in the coastal area suddenly now have to truck or carry water in from outside because the water wells they've depended upon have now become salinized and are not useful for human drinking or other purposes. It's also true that you can have problems originating in the larger aquatic environment that affect the organisms that may not kill them but may have an adverse impact on us as consumers. And this is something that you may be familiar with in terms of particularly filter feeders, the shellfish, mussels, clams, oysters. You may not have noticed, Jillian, last night I didn't eat those those mussels that were on the plate with my deal. I've been studying this long enough that I'm not suggesting you follow my behavior, but I try to stay away from shellfish, filter feeders where I don't know exactly where it's come from, right? Particularly raw. But there's other things that we might pick up from fish as well. And so you need to know something about the environment where the animals are grown and know what the possible direct human health consequences may be. One of the other ecological impacts of aquaculture is that we are rather promiscuous in terms of introducing exotic species from one place to another. Up on the upper left here is the Penaeus vanemi. It's a shrimp that is common in this area, the far eastern tropics of the Pacific Ocean. But it's a species that has been adopted widely around the world, and it's now the primary species of shrimp that's being used because of its, because in Hawaii there's the Ocean Institute that's created a brood stock that is disease-free and has become sort of the center for the distribution of this species. Doesn't mean the shrimp are disease-free because they run into pathogens in the environment where they're grown out. But we now have the Penaeus vanemi that are origin here are being grown in this area where I'm working in Brazil. They're being used in Vietnam. They're being used in Indonesia, Philippines, Malaysia, Bangladesh, and India. They're all over the world. So it's an exotic species now in most parts of the world where it's found. How about salmon? The Atlantic salmon we see being grown in British Columbia and a little bit in the U.S. Some over here on the West Coast as well. That's at least the same ocean. But we're introducing salmon as an exotic species living in those cages, and there are escapes, and there are breeding populations being established in the Pacific Northwest. We're also raising salmon down here in Chile, Atlantic salmon. That's a long way away, right? And I don't have any information on breeding populations being established there, but I would not be at all surprised. And of course, once we start introducing the intraspecific hybrids of blue and channel catfish and the transgenic salmon, which may be grown anywhere that they're growing salmon, we have even more complications in terms of environmental impacts from the introduction of exotics. So fish diseases are a problem. So are parasites. These ugly little things here are sea louse, and they will attach themselves to fish. And in the wild, they're not necessarily a major problem. Where do they become a problem? When you've got these cages filled with, in dense populations, lots of fish. And those lice, once they have all those hosts readily available with not a lot of space between them, sort of like those of us in this room, if somebody had a really bad disease, it's likely that all the fish in that pen are going to have the ocean louse. And then what happens when wild fish pass by? So we're creating host environments where parasites and pathogens flourish, no different than humans. And just as we sort of eradicated TB, not eradicated, as we controlled TB with various ways of reducing the density of human populations, it's the same thing we're facing with here, not TB, but the same kinds of issues associated with density and health of the animals. So we have danger not only of the animals that we're trying to raise getting sick and then are having to use antibiotics or other ways of treating copper sulfate and other chemicals, but we also have the possible impact on wild stocks as well. I was mentioning earlier probably should have brought the slide further up, but the environmental impacts, ecological impacts of aquaculture are not necessarily only local, particularly when we are raising carnivorous species like salmon and shrimp, which are the two largest in terms of volume and value of production around the world. I should actually back off that volume point because carps in China are maybe something a little different here, but the aquaculture data on China are a little murky. These pictures represent three different species. The anchoveta, the menhaden, this big ferocious looking thing is actually about this big, and the capelin. And these are the key three species that we use for fish meal, that 20 million tons that I was talking about earlier. Aquaculture, particularly those aquaculture for the carnivorous species, depends on these species for the fish, for part of the protein intake that they have. All these carnivorous species depend on fish meal. They can't eat, so they don't thrive on soybeans. Tilapia, carp, catfish, fine. But the carnivorous species require fish meal and fish oil, and there's a limited supply. So we're pushing the ocean environment to produce enough fish meal to support that 47% of the world's fish that we're growing for human consumption in aquaculture is coming from these guys, these little fish, which are the base, well, not quite the base, the copepods and things like that are, but these are, you could call this pretty close to the base of the oceanic food chains, and we're harvesting them to feed into other species for our own direct human consumption. When we talk about aquaculture, we often talk about a range of production systems from extensive to intensive, and yeah, most of the world is somewhere in between, most of the world of aquaculture. When by extensive, what we mean are the kinds of systems that may have been in place in Indonesia for a millennia or more, that during high tide, the gates of a pond would be open, and before the tide starts to recede, you close the gates and you let things, whatever came in, you let it grow for 6 months, and then you harvest whatever there is. It's no input other than a little bit of labor managing the water. No feeding, no supplemental stocking. That's pure extensive. It's a very natural system. The other extreme in the intensive system is when you are using very high inputs of stocking, very high feeding, because you put a lot of animals in there. You can't rely on the natural productivity of the water. You've got to feed commercial supplement feeds. And you may be using drugs, you may be using aerators, these little paddle wheels throw up water into the air, aerates. This is necessary because in this pond they've probably got so many fish or shrimp. They've got a lot of uneaten feed that's decomposing on the bottom, a lot of fecal matter that's decomposing on the bottom. All of these are driving oxygen demand, and unless you aerate, you could lose your whole stock of fish or shrimp in a pond without these kinds of aerators. So wherever you see these aerators, you know you've got a pretty intensive operation going on. So more inputs all involve money, okay? These things cost money, these aerators. The energy to run them costs money. The feed, the stocking materials, the drugs, everything else costs money, including talking about groundwater and surface water. If you're having to supplement your water by pumping in surface water or groundwater to keep the water up. In the tropics, evaporation is an issue. All of these things take money to operate. On the extensive side, typically small scale, very low inputs, your ecological burdens are not as high as they are with the intensive systems. But the intensive systems are very attractive because you can make a lot of money, a lot of yield. In parts of Southeast Asia, it's not uncommon for in a square meter of pond area, and this is water that's 1.5 meters deep, let's call it, you might have 750 shrimp stocked in that, post-larval shrimp put in your pond. Not all of them will survive, but survivals might be in the mid 80%. Look at that table, just imagine that's a square meter. 700 shrimp, 750 shrimp, pretty dense. They can't rely on natural foods and water to grow. You've got to feed them. They're all pooping. They're not eating all the feeds. They're decomposing. So there are impacts of aquaculture and very intensive systems. In salmon, just shows where salmon's grown around the world. And the point I wanted to make here was in Chile, you'll see it started relatively small, grew pretty dramatically, pretty large portion, not as much as Norway, but significant production in Chile. A little drop off here. What's going on? Bad management of the industry. And I understand you had a talk here on salmon in Chile recently. Is that true? Did I get that right? Yeah? Okay. One of the problems they had in Chile was that they put too many pens into the fjords that they have in the southern part of Chile, and you had disease problems emerge. It was a bad management, not in the business sense directly, but in an ecological sense. They had too many fish, too close together, too much stuff going down to the bottom of the fjords, and too many disease organisms just simply because of problems of intensity of production. So when we think about aquaculture, we have to think in terms of aquatic ecology. The fish, the shellfish, the algae, everything else depend on water availability. We have to recognize there may be conflict. We have to recognize that issues of quality are important. There are these things there's this concept of carrying capacity. There's only so much that you can put into a body of water before you start pushing that system beyond its boundaries. And maybe you can do aeration, and maybe you can do other things to mitigate some of the environmental burdens that you're imposing on an aquatic ecosystem. But ultimately, you have to work with the ecosystems that you have. Yes, we can modify them. We heat and cool rooms. Sure, we can modify aquatic environments to a limited extent as well, a little supplemental feeding. But if we push the systems too far, and that has been the nature of aquacultural development, moving increasingly toward intense systems, we end up with all kinds of problems. And these have to do with disease organisms and overutilization of water resources and the like. Nature bats last. Oops. And so we need to understand that we have to work with nature and not in conflict with nature in order to have an aquaculture system that is sustainable. And I see that the next talk that you have in this series is addressing those issues. So this is a study of that FAO, Food and Agriculture Organization of the United Nations, has done. The third part that I want to get to here has to do with the international public health dimensions. And the key part that is always issue that has always concerned me is the movement of high-value animal protein from the global south, where protein insufficiency is a problem for public health and nutrition, to the global north, like here, where protein malnutrition isn't the problem. Well, maybe malnutrition because we eat too much protein, but we're not in a protein deficit environment here. How does that happen? Why does this happen? Well, it's economics, it's power, it's money, it's market power that we have as global consumers. And anybody who's not a capitalist here, I mean, we're all capitalists, right? We're all part of the capitalist global world system, right? Markets rule. And so if I'm willing to pay $10 a kilo and someone else is paying $8, I get the product. Well, those of us in the global north are able to pay that $10 or whatever the figure may be for the product because we are able to pay, we're willing to pay more than other consumers. So here we've got shrimp being packed up in South Vietnam, and you'll see Pangasius catfish in a little bit. But the point that I'm making here is that much of the product that we grow, and in the tropics, shrimp in particular, is exported to the north. Seafood, the value of international seafood trade in 2008 was $102 billion. 15% of that was shrimp. Big deal. Shrimp is a big deal. Global trade in seafood is a big deal. And it's almost all going from the global south to the global north. If I had any talent, I would be a political cartoonist. I don't, so I'm not. But it's about money and power, right? And that's what's driving ecosystems, and that's what's having public health impacts associated with aquaculture. So what we've got is a desire to generate foreign exchange. The investors in aquaculture and the processing and export businesses, they want to make money. The governments support this because they want foreign exchange earnings. Foreign exchange earnings can be used for many good things. Tools to build industry, medicines to improve public health, or we can buy weapons and luxury goods for the local elites. So it's an empirical question. I'm not necessarily and diametrically opposed to the idea of exporting raw materials, natural resources, even foods. It might be the right decision to make. Look in each individual case and decide what those foreign exchange earnings are being used for, and you can make your judgment. Different countries, different priorities. So, but the point is, we are still moving product from the global south to the global north. And in some parts of the world, Southeast Asia, where I've spent a lot of my time, more than 60% of the total protein, animal protein consumed by people in Southeast Asian nations comes from seafood. It's a pretty fishy part of the world, very maritime kind of part of the world, so maybe not surprising. But what we're doing is shifting a lot of that product to the global north, and not only from aquaculture, from capture fisheries as well. And this picture sort of gives you the idea that this is oriented around the marine fisheries sector where the stocks are static or declining. And so the consumer is saying, well, I'll have some fish while there's still some around, before they're all gone. We're not in that situation because of aquaculture. Aquaculture is the potential for the future for providing seafood, fishery products, crustaceans, et cetera, for our consumption. It's not a bad thing. I'm not trying to suggest it is. Sociologists, social scientists often are pointing out problems. That's how we address and resolve problems, is to talk about what those problems are. We do have the potential through aquaculture to help feed the world. Everybody, all walks of life. I believe that. I'm an optimist too. But I also understand that there are market forces that have driven aquaculture in certain kinds of directions. We have the ability through policies and international development activities and policies in the national governments around the world, in the global south in particular, to shift our focus away from the high-end consumer goods and toward smaller scale production. Now, I focused largely on the salmon and shrimp, but we also have tilapia. Tilapia is a wonderful animal. It's really hard to kill. If you're going to start out as an aquaculturist, start with tilapia. They're very tolerant. And in the development work early on when I was starting with this in the 70s and 80s, tilapia in backyard farms was all the rage because they were so tolerant. You could grow them under all kinds of conditions. But tilapia has now become a good that you see in all your markets. I mean, all of you have probably eaten tilapia or at least seen it in the market or in the restaurants. 20, 30 years ago, it was a peasant food. Now it's okay. Now we dress it up and it makes it look nice. We had development projects that were supporting tilapia production for local household consumption and local rural populations. And once they realized that this is a product that you can sell globally, bam, we've moved it out. We're even shipping tilapia out of the developing world into the U.S. markets when that was not the original intent of the development efforts that brought the species into production. Pangasius catfish from Vietnam, another species that had been used locally for local consumption. You may or may not know it. You've probably all eaten Pangasius catfish. If you've eaten catfish, there's a good chance, 50-50, that it may not have come from the American South. It may have come from Vietnam. They grow it in very large volumes. In fact, the catfish industry in the United States is struggling with high feed prices and low fish prices. The low fish prices because of international competition. Still, even though it's driving prices down, it's still higher than the consumers in Vietnam are able to pay for this fish. So we get it because we're willing to pay the higher price. And it's having an impact on our local producers as well as impact on the fish availability in Vietnam. There are a number of issues a couple of issues I'm just going to mention very briefly in passing because I'm not an expert on them, and there are probably people in this room who are far more expert than I. One is antibiotic residues, particularly in intensive operations of finfish and crustaceans. Producers use antibiotics even though they are banned by importing nations. The United States, the EU have absolute bans on antibiotic residues, but still they're being used. We simply don't catch it all. So there are issues associated with antibiotics in an aquatic environment and how that might affect antibiotic resistances of pathogens. The other issue, which I first read about 15 years ago, almost 20 now, is in Southeast Asia and southern China, where you have integrated aquaculture involving fish, ducks, and or chickens with pigs. That this is an area, a part of the world where many of the flu pandemics originate, and it is this integrated aquaculture that is critical to, some people say, and it's disputed, so I will leave that debate to someone else. But just to mention, in the context of international public health, sometimes aquaculture, by bringing the fish are the ones that integrate the pigs and the birds into a system, that this may have something to do with public health issues that are not directly related to aquaculture and the kinds of things I was talking about. Where we should go, where we should be putting our emphasis are in the small ponds like this in backyards, where producers are not full-time only raising fish or shrimp, but they're the kind of backyard farms that you can, ponds that you can feed garden wastes, kitchen scraps, raise some fish. You could have probably 400 or 500 kilos of fish in a pond like that, more than a household necessarily needs. Some barter, some trade, a little bit of sale, a little bit of cash, but not all the eggs in one basket, not all your fish, not all your livelihoods based on one activity, but involving a number of different activities. And this reservoir can also be a reservoir for irrigating vegetables and things like that. Integrating aquaculture into a wider suite of activities rather than specializing and moving toward the high intensity, specialized, and therefore vulnerable production system is, to me, the right way to go, where a modest level of inputs can be used, production systems like this can be very sustainable. It's affordable to a wide range of people. Not everybody, because you've got to own some land, right? If you're completely landless, you're not going to do this. But you may have access to an inexpensive food source of good protein in your rural area. Particularly as you move away from the coast and you move into the interior in developing countries, or the United States for that matter, on the coast is where you find a relatively abundant seafood. As you move further and further away from the coast, Auburn, Alabama is a good example of that, the quality of seafood and the price go inversely. So why not promote fish farming on a relatively small scale in areas like that, particularly in the developing world where the smaller scale operations fit into the nature of the local economy, and you can buy goods, and this is from northern Brazil. This is actually Dr. Juliana Lima, who has her PhD in aquaculture engineering from a German university. I've been working with her for a few years. And this is a market, just a local market. There's local shrimp farmers, and they're just selling the shrimp locally. Even shrimp can be fine, can be a locally consumed good. They're not tied into the global market. It's a very low intensity operation, looking to find ways that aquaculture can provide high quality food to local people that's not otherwise available, and allow the people doing the work of raising that food an opportunity to make an income and feed themselves in the process. Thank you very much.